Hello and welcome to part 4 of Back from Thailand RCA U 42. This will be the last installment of this series. Come hell or high water, I am going to make this the last one. However, I am reshooting a section of this. This section of the video, or some of this video, will be reshot. I woke up at about 2 a.m. last night with something just nagging at me, and it was the fact that when I did the alignment with the sweep generator, I did not disable the AVC. I did lower the level of the signal generator and to the point where the AVC action in the tuning eye was just a little flicker. However, as I had mentioned in a couple of other videos, the people who make these signal generators, the Series 200 signal generators, in their book, Servicing by Signal Substitution, had mentioned, in fact they mention it several places in that book, that you should give some serious thought to disabling the AVC and using the signal generator AVC output here to set a mean voltage, so that while you're adjusting the IF transformers, you're not getting a fluctuating voltage on the grid of the tubes. And if your radio is going to be used in an extremely strong signal environment with a lot of AVC voltage, you could put this up near the peak of the AVC voltage. If it's going to be used in a rural area, you could set your IFs with a very low AVC voltage if they were only going to see very weak signals, because it alters the capacitance of the tubes, the grid capacitance of the tubes, and alters the IF curve. I didn't present one of these because I didn't think I had any more. I'm quite the pack rat. I think it falls short of hoarder because I sell too much stuff at the flea markets to be called a hoarder. I usually go to the flea markets with a pickup truck bed loaded with goodies to get rid of, and I've been known to come back with a couple $1,000s in my pocket just in incidental stuff. I had 3 of these at one time, and I thought I'd sold all 3 of them, but it turned out I guess I only sold 2 of them. These have been fully restored, fully repainted. These things look great and they work well, but I kept the ICO unit that I have, that ICO unit there in the background. I just like that big tuning dial on it, and figured I'd hang on to that and get rid of these. It had a better band spread on the dial, yada yada yada. Anyway, I like the ICO. I had sold off 2 of these, and this one was in the truck to go to the flea market. In fact, last fall I had a pickup truck full and a trailer full of stuff to go as I was heading out to Thailand. But the weather took kind of a turn, and I really didn't have the time to deal with going out there to try to sell stuff covered up in the rain. I was getting ready to leave, and I said, screw it, I'm going to leave the stuff stored up in the barn for now. So I went up tonight and poked around and found one of these E200Cs. It's one of the 3 I have left. But I had talked about they had an AVC control, and there it is. There's the AVC output, and this is the control for controlling the AVC voltage. That'd be 0 volts, 5, 10, 15, yada yada. So I am going to reshoot a section of the video of doing the IF alignment, because I've run a couple of experiments, and sure enough, the AVC voltage has a pretty big effect on the tuning curve of the IF. I had actually reassembled the receiver. Everything was back in the cabinet, tied down, all the wiring harnesses were dressed back in. And I got up this morning and said, the hell with it, and took everything back out of the cabinet and spread it around here on the bench so I could run the tests, because I just felt the video wouldn't be complete unless we did the AVC disable and put a fixed bias on the AVC. Now, I'm not going to use this for the AVC voltage. It takes up a lot of real estate on the bench. I've got a little power supply here that I built, oh, probably back in the 70s, late 70s, because I needed a little bench supply and I didn't have anything, and I put that together. The funny thing is, I was watching a video, Fran Lab, I think it is, and she had one that's so identical to this I had to do a double take. I had to ask myself, had I sold mine and somebody in a flea market had bought it, because it's virtually identical to this. And that's something I built, but she has one on her bench that's almost indistinguishable from that. It set me back on my heels to see something as close to that one as as hers is. At any rate, oops, I'm going to get this off the bench. We're going to get set up. We're going to show you how the voltage on the AVC affects the tuning of the IF strip. And we're going to try to set it. Correction, we're going to set up the AVC voltage at a fixed bias and demonstrate how the change in AVC voltage affects the tuning of the IF strip. Thanks for stopping by. This is going to be a little bit pieced together, but I thought this part was important. Okay, here's where we pick up with the new reshot video, where we're going to set a fixed bias or fixed voltage on the AVC line. So a quick rundown of the schematic. Please excuse the dappling on here. It's late afternoon, 6:47 in the evening, and the sun's about to go down, and it is beating against the Venetian blind over here. There's nothing, well, I guess I could hang a blanket over there, but we'll deal with it. Our IF, we have our converter, first detector, whatever you want to call it, feeds to the first IF can, goes to an IF amplifier, the 6K7, second IF transformer, comes out of the second IF transformer and goes into the diode plate here to be rectified as audio and AVC voltage. For some reason they've chosen to ground the second diode directly to ground instead of using that for AVC. They've combined the audio detection and the AVC in one. It's not uncommon to do that. I just don't know why they don't use the other one. Some designs do. There's probably a reason for it that I don't understand. At any rate, after it, oops, stand still, buddy. After it's been rectified, our audio and our AVC DC passes back through this coil. We have an RF bypass to ground here. And between this capacitor and this resistor, we've got a pi filter to get rid of most of the residual RF that's being carried on that line. We don't want RF getting into our audio, and we don't want it feeding back into our IF amplifier or our converter, because you'll end up with oscillations. So you have to bypass that RF to ground. The fluctuating DC comes down, develops the voltage across this resistor. This capacitor passes that fluctuating DC voltage or AC voltage, audio AC, down into the switch, into the volume control. The switch is just for phono, Victrola, AM radio, so on and so forth. It's just a selector switch for the source. Then off to our audio amp. What we're interested in is right here at this junction. There's a 5.6 megohm resistor that carries our AVC voltage over to our IF amplifier tube. The AVC voltage goes up through the secondary of this transformer to the control grid of this tube to control the gain on that stage. Another line runs down here, runs across. We have another bypass capacitor because this is going into our first detector oscillator converter tube, whatever you want to call it. Carries up here to the grid and controls the gain on this tube. Now if any of this RF got back into here, we'd have a howl and you'd have massive oscillation. So this is bypassed in several areas to get rid of any residual RF. Also picking off of this AVC line, Down here is another line that goes to our tuning eye tube. Control grid of that so that we can have our tube open and close depending on how strong the signal is and how well you're tuned in. That's your tuning eye that changes, the AVC voltage changes with tuning. When I was doing the alignment yesterday, even though I was keeping the level low, I was seeing this tube fluctuating. Last night I woke up and I said if the tube's fluttering, the AVC line's fluttering, it's got to be affecting my IF tuning. I decided to take the radio back out of the cabinet and reshoot this section because I thought it might be of interest, and it certainly is going to demonstrate what's going on. So I am going to break this connection right here. I am going to inject a fixed voltage into this 5.6 mega ohm resistor to control the AVC. I've already measured the voltage from no signal condition to fully closed on the tuning eye, and it goes from about 1 volt up to 10 volts. So we're probably going to shoot for around 4 or 5 volts on the AVC line to do our tuning. I'll get this out of the way. Well, why don't I just pull it out of the way. And down here, here's that 5.6 mega ohm resistor. Here's my negative AVC voltage coming from my little power supply, which is sitting right there. Here's my signal going in to the converter tube through my DC blocking capacitor. Now I've made up a bunch of these little blocks because sometimes they say use a 0.01, sometimes they say use a 0.1, sometimes it's 0.05. All I've got to do is plug this block into my signal generator line, and I've got my blocking capacitor and the correct coupling. This is picking off from the audio line where I broke out the 5.6 mega ohm. I removed that from the junction here, so I'm just going to be picking out the detected signal there, going into a little demodulator block that I built. This is nothing more than a couple of germanium diodes and a small cap. I made a voltage doubler, so if the signal is very weak, it boosts the signal up a little bit for the scope. And it also serves the purpose of reversing the polarity. The polarity on the AVC line is negative. That would result up here on the scope. I don't think we're going to see that from this angle. I can see the scope, but you can't. Anyway, let me move the camera. Okay, by reversing the polarity in my little demodulator block, we get a positive peak on the scope. If we didn't use that demodulator block, or that if we didn't use that demodulator block, I could simply hook an oscilloscope probe up and pull the signal directly out of the detector. However, that would be a negative peak. You'd be looking at a downwards pointing peak. It'll work fine that way. There's nothing wrong with that, but this is just more intuitive. Up is more. That's the only reason I did that, is just it's more visually appealing, I think, and it's easier for people to understand if they see a positive going direction for increased sensitivity in the IF strip, or increased peaking, I guess, however you want to phrase it. Okay. We'll do a little demonstration first. The first thing I'm going to do is I'm going to disconnect this and temporarily hook up the original AVC line again. So now the radio, let me disconnect there. What am I hearing? Oh, is that the camera causing that? I hope not. It wasn't doing that before. Let me figure out where that noise is coming from. Okay, that was indeed coming from the camera, or more specifically from the stupid Chinesium power supply. So we're running on battery right now. And I'll probably have to go find a better power supply because that one's obviously a piece of junk. Okay, we have the AVC line reconnected. What you're hearing, that little puttering, oh, there we go. That was just the sweep generator that shut off. Now I'm gonna tune in the station.
That they be recognized, and I think we can do that. I think we can do it safely.
In fact, why don't I demonstrate? Let me get the voltmeter hooked up. We have the voltmeter hooked up now to the AVC line. We are on the 15 volt scale. So right now we have about half a volt on the AVC line. I had to put the cardboard here to get the sun glare off of the meter face so you could see it. It's not perfect, but it's certainly better than it was. Now I'm going to tune in that one station that I can get.
Jeff Manasso, Fox News.
In Holland, the Prime Minister says bars and restaurants will be allowed to reopen June 1st with limited numbers of people and social.
And as you can see right now, we have about 4 volts of AVC. Now I'm going to stand the antenna up. Presently the tuning eye is just starting to close a little bit because the antenna is laying down and we're not getting a lot of signal. You will hear a small increase in the strength or the volume, but it is being mitigated by the AVC line. When I have the antenna stood up, I will disconnect the AVC line.
The restaurant did away with the charge altogether. The added charges appear to be perfectly legal as long as they're disclosed before your purchase.
Okay, it wasn't connected, sorry.
And HBO along the 2020
You can see the voltage has gone up. Now I'll lay the antenna down.
Academy of Digital Arts and Sciences announced the winners earlier today.
And there is a change in volume, but it isn't huge.
Individuals and organizations who are using the internet in response
You
to
see
the
right now we have about 8 volts on the AVC. Actually, we can get it better than that maybe. Anyway, we're going to go down here, lay the antenna down again. The AVC drops. Now I'm going to disconnect the AVC. Now I'm going to stand the antenna up.
Behind notice against drunk driving. News Radio 610 weather.
And you can see how it just totally ran away. It became distorted, overmodulated. There was just too much signal strength. So the AVC is doing its job. We'll connect it back. I think it's going to be touching. There we go.
Partly sunny, highs in the mid to upper 70s, and we'll go
there. Now we have AVC action.
Friday with sunshine. From the Stormwatch 9 Weather Center, I'm meteorologist Haley LaPointe.
For victims of drunk and drug driving.
Now, I'll hook up the manual version of that.
Our 24-hour victim helpline.
We have negative to the AVC, positive to ground because the AVC voltage is a negative value. Turn on the power supply. Now, that AVC voltage you're seeing there right now on that meter is meaningless because it's disconnected. That's just being measured with the voltmeter. The AVC is now being supplied by this.
It's the Dave Ramsey Show.
You can see as the voltage drops, the gain goes up. As we increase the negative voltage on the grid, the gain goes down.
Entree Leadership Theme Hour. Welcome to Small Business Land as we talk to leaders and owners of small businesses.
And that's how it operates.
Questions about business, questions about leadership, questions.
Now I will hook up.
888-825.
You can see I can almost cut it off on a weak signal. And then bring it back.
Daniel is Executive Vice President of Entree Leadership, or we teach.
And cut it completely off. That's because the signal's so weak I can turn the gain down enough to completely block the signal. I will now hook up the sweep generator and we will watch the effect on the oscilloscope with the various voltages. And I'll just turn the volume down while we're doing that so that it isn't blasting us out of the room. Okay, I think I've got most of everything in frame. It was a little hard to do between the light reflecting off the wall behind me. I finally moved stuff around so the scope can be seen. And we've got the little power supply over here. And we can see the radio. The only thing you can't see in the frame is the attenuator, but that's alright. You know what an attenuator looks like. I had a couple of junk cables I had to get rid of. I had all kinds of problems here setting this shot up. But we're up and going. Okay, I hope it's visible in the shot. Let me zoom in here just a little bit. You can probably see that the left-hand side of the sweep is a little bit higher than on the right-hand side. Right now, we are running about 1 volt of AVC and very, very weak signal. I have almost all the attenuators switched in on the attenuator, so there's very little RF going in to the IF, and the gain is way, or the voltage, AVC voltage, is way down. So the gain is very high on the IF strip right now because there's very, very little signal going in, and there's no AVC throttling it back. I'm going to add some more signal, and I'm going to redo the scope, and we can see we have a very definite peak over on the left hand side. Now I'm going to reduce the gain of the IF strip by introducing some AVC voltage, and the curve has not only flattened out, it's starting to rise on the right hand side. Same signal strength, just we've reduced the gain of the IF strip by adding some AVC, some negative AVC voltage to the grids. However, because of the change of capacitance in the tubes in the IF strip, or the tube in the IF strip, we're starting to see a different tuning curve. Right now that's about 4 volts. I'll add some more signal. That's too much. We're overpowering everything. Let's see if I go, there's another 10 dB. And we still have a little bit higher on the left hand side. Now I'm going to add some more AVC voltage, and look what's happening. The curve is now coming up on the right hand side because of the change of capacitance of the tubes. Add a little more signal and it's very, very clear here. You can see the rise on this side of the peak. So that has altered the tuning of our IF transformer over what we did in the previous, or what I did last night when the AVC was not disabled. I was running the AVC so that the tube last night, so that the tube was just beginning to close down the I tube. Now I'm going to reduce the voltage. That is about where I tuned it last night, and you can see the peak on that side. It was probably even less than that, because if I reduce the voltage some more, or it probably was more than that, excuse me, because if I reduce the voltage more, you see that peak come up. And if I increase the voltage, I can level it out. What does all that mean? Well, since the only station I can get is fairly strong, I guess I'm going to leave it where it is. Let's put some more signal in there. That's overpowering it completely. That's about 4 volts, and I'm a little bit of AVC. I'm a little bit peaked over here and a little bit low there. So if I was going to do anything, I would probably bring my AVC up to about 5 volts or 6 volts. Because it's a fairly strong station that I'm dealing with. And maybe just touch up my tuning a little bit to bring up this side of the trace, to swing my IF. What's going on there? More flaky connections. I'll probably bring this side up a little bit to even out the IF curve, Right now I've got -6 volts on the AVC. That should be a good compromise. I've got a flaky connection. Okay, we're squared away. Don't buy cheap BNC cables. I know it's expensive to buy good ones, but it is just not worth the heartache of buying some cheap ones. I bought a bag of cheap ones figuring I could get away with it for low frequency stuff. They are just worthless. So they'll end up in the trash can at my next flea market. I'll just scour the flea market for BNC jumpers and bite the bullet and pay for them. Anyway, I am going to retouch the IF. I won't bore you with all of that. I'll do it offline and we'll call it a day. But as you can see, I just wanted to demonstrate what the let me get the book. I wanted to demonstrate what they were talking about in servicing by signal substitution. How if your customer back in the day had very, very strong reception, was living very close to the AM station he was listening to, you might want to reconsider tuning the IF at the lowest signal, inject an AVC voltage that's more in line with what he'd be seeing with a strong signal reception, and tune your IF curve there. Obviously it makes a difference. I've got some of the best audio out of this thing I've heard yet. Now I'm sure it's not translating to the camera well, and there is a lot of background noise on the signal, but the audio is opened right up. I was able to actually attain the classic double hump, but the IF is way off center. I had to tune way off the band, or way off from where it was supposed to be on the dial, to shift the IF rate, to shift the oscillator back so the IF was in the center, or to shift the heterodyne signal back into the center of the IF curve. Let me put that up on the screen. With the fixed AVC, I was able to attain the double hump that you would do for an FM signal or an FM receiver. So now we have some serious bandwidth on the IF. However, there's our 455 kC marker right here, so you can see we've shifted down in frequency quite a bit. I suppose I could take the IF cans apart and change out the 56 picofarad caps that are inside of the cans to something of slightly less value, maybe 40 picofarads. I bet I could move that whole thing back into the center. I don't think it's worth the work. It might be a fun experiment, but when you're messing with IF cans that are from the 1940s, all I've got to do is break a wire in one of those coils and that's the end. So rather than take a chance on damaging the IF transformers, I'm not going to mess with them. But I certainly could, if I wanted to, lower the capacitance a little bit inside those IF transformers. Actually, you could take a few turns off the windings if you were really brave, and shift the whole thing back into the middle of the 455 kilohertz. I could not attain that when the AGC was running. It was messing with me because every time the sweep came up and it started to come into the resonance point, the AVC would shift it back down, so I couldn't see that double hump. So I'm going to tune it back to where it was. Okay, with a little more playing, I was actually able to pull that back over, and I've got a little bit of a double hump there right in the center of the bandpass. Not bad. I'd like to see either this side roll off a little sharper or this one roll off a little less, but if you look across the 4 kilohertz here, this is 2 kilohertz, this is 2 kilohertz, about 4 kilohertz. That's a lot better than the 1700. Is that right? 2, 4, 6, 8, 10. Yeah, it's about 2 kilohertz, 4 kilohertz of bandwidth. Not too bad. It was somewhere between 15 and 1700 before. And if I roll the voltage down, you can see that side goes up, and if I roll it up, the other side lifts. But that right there is about where the station comes in. 6.5 volts. I've lost a little bit of gain but that's okay. I think that's going to sound pretty decent. Let's give it a try. Okay, the audio, excuse me, the audio sounds pretty good.
For my mom to get my dad out of the business would be so that she's free to have full autonomy in the business.
That speaker sounds a little boxy, of course. It will sound somewhat better in the cabinet.
Yeah, no, they sadly have not divorced yet, and it's been about 2.5 years.
But I have definitely lost some gain on the IF. I have the AVC hooked back up, and the tuning eye won't close. It goes about 3/4 of the way closed and then stops because I have tuned the IF to be broad and not peaked. So I've lost sensitivity, but I've certainly picked up audio bandwidth.
Living off of not unemployment.
So the experiment was a success, more or less. I did prove that we can pick up some audio bandwidth by stagger tuning the IF. Now what you choose to do is absolutely up to you. I may peak this up a little bit again just to get a little more sensitivity out of it, but it certainly does open up the audio when you stagger tune the IF a little bit and get some bandwidth out of it. I guess we could call this the end of the video. Call it a night, put this thing back together and go to bed. Thanks for riding along with me. I hope somebody found this entertaining, educational, fun, interesting. I don't know. Give it a thumbs up if you like it. Give it a thumbs down if you don't. To the guy out there who didn't like my political speech, to hell with you. I really don't care. When your kids are being cut up for organ transplants by the Chinese Communist Party when they take over, you'll get it. It'll be too late though. At any rate, if you don't like my politicizing, move along. Find another channel. And for the rest of you guys out there, thanks for listening. Appreciate it. Have fun. See you soon. Oh, we'll be back real soon for the Howard FM. Bye-bye for now.